bonding and anti-bonding is formation. The combination of orbital to form a bond in the form of wave function. Either it is form of a crust or trough, or trough to crust. The positive lobe is interacted with negative lobe, and negative lobe is interacted with positive lobe. This type of a lobe is interacted, then there is a formation of an bonding and anti-bonding. In addition of atomic orbital form and bonding molecular orbital, which is has a higher electron density between the nucleus. Means if bonding molecular orbital formation, there is a formation of an high electron density at the nucleus. But subtraction, there is a formation of an anti-bonding. Means there is a formation of a node means where the electron density found is 0, or we can say between the nucleus. These type of a wave function, as the wave in the form of an parabola, this positive lobe is interacted. This positive lobe is in the form of wave first up down, and then down, then up down. This is the wave function. Either it is in form of or a positive or negative. But if we compare it with a negative lobe, negative means it is in the form of an trough. This is the trough, amplitude in the negative direction. But if its amplitude is in positive direction, then it is a trough. Means it is in bonding direction, bonding. If it is in this direction, anti-bonding molecular orbital, ABO, anti-bonding molecular orbital. Like if we take an example, there is a formation of a hydrogen. If that hydrogen is subtracted, means there is a formation of an S and S, positive, and here is positive added to form an bonding. Means sigma bond formation and electron density in this case is increased. But if positive lobe is interacted with negative lobe, there is a formation of an subtraction, and there is a formation of an node where the electron density found is 0. This is an anti-bonding molecular orbital. The bonding molecular orbital has a higher energy as compared to anti-bonding. This is we have already discussed in last class. As the some student has a doubt of how we calculate the bond order, there is a formation of first is molecular orbital diagram. In molecular orbital diagram, there is a different molecular orbital that is combined with each bonding orbital or anti-bonding. Electron are filling according to energy level as fill one by one according to Affa principle and Pauli exclusion principle. According to bond order, or when we calculate the bond order, and the bond order formula like this way: half of bonding molecular orbital minus number of anti-bonding molecular, and the bond energy is directly proportional to bond order. How much bond means that greater has energy. Means if it is a 2 bond order, higher energy, 3 more higher, less energy, and bond order is inversely proportional to bond length. Means if bond order has higher, then bond length smaller. In case of a double bond length is smaller as compared to. Next, this is the main, we have already discussed how these type of a atomic orbit combine to form a bonding as well as anti-bonding molecular orbit. In this case, if we take an example of hydrogen, in case of a hydrogen, one electron are filling, one s one. Here is one s one, one s one, total two electron. First filling in bonding atomic orbital and sigma bond. After anti bonding is unfilled, means total two electron, and according to a electron field according to its energy level. It has less energy, it has higher energy. That's why electron field in this orbital, and electron first fill in this direction, after that it is fill in direction. Then the total bond order is of total number of electron in bonding in 2 minus anti bonding, that is in 0. Then bond order of hydrogen is H and H. This is the bond order. Only one bond is formed, and the bond energy in this case is high, is less. Then next is, if we take an example of H helium 2, in case of a helium 2, there are total 2 electron, 1 s 2, total 2 electron in this and 2 electron in this, total 4 electron. 4 electron in this case, half 2 minus 2, that is 0, means helium does not dimerize. Bond order 2 means helium only exists in form of He, not He2. He2. And electronic configuration in this sigma 1s2, this is sigma 1s and sigma star 1s, 1s2 and sigma star 1s2. After that, if we take an example of this, uh, there are two type of a energy diagram. In case of oxygen fluorine, there is an there is a formation of an sp mix. This case, sp mixing in this case, that's why it has s and p has less energy. That's why the pi 2pz, pi 2px, pi 2py has less and less. And in this case, sigma 2pz has less energy. 2pz, 2px, pi 2py. And the electron are filling according to its energy level. This is the main difference between this and this. Are filling according to its energy level, but in this case, boron, carbon, nitrogen, due to smaller size, there is a formation of an sp mixing, and 2py participate in 2pz has less energy as compared to sigma star, as compared to another. Let's discuss with heteroatomic. Now we will come to atomic. Heteroatomic means in case of a homo nuclear, like a B2, C2, F2. Two s 2, 2p, 5, 2p5. Total 5 electron in this case, and 1s. It has these 1 and 2 does not participating in bonding. That's why it come in non-bonding. That's why it come in non-bonding orbital. And these P and S has a comparable energy. Comparable energy means these type of a atomic orbital mixed together to give molecular orbital of a sigma, this sigma. After that, another remaining orbital come in non-bonding molecular orbital. That's why in this case, total 1 electron here and total 5 electron here. Total 6 electron filling one by one, then sigma sp2 and pi 2, uh, non-bonding p px sigma non-bonding py, this way. This is the electronic configuration. Right? The sigma star coming in non-bonding. Every bonding that has corresponding to anti-bonding, but the remaining orbital come in non-bonding. Here is total, where we can say total 4 orbital, 1 and total 3. Total 4 orbital has a chances 1 bonding that corresponding to anti-bonding, but remaining orbital non-bonding. If it has a another atom participate, if it has an if we take an of HF instead of H, we can take is a B, boron. In case of a boron, there is, then the p orbital is participating is p. That's why there is a formation of a different scenario, like we will discuss in next slide. HF, please raise your hand. Next, in case of a NO, if we take an example of NO is also in NO, nitrogen, oxygen. Here is the here is oxygen. In of a nitrogen, it has a different, and if we take a nitrogen, 1s2, 2s2, 2p, 2s2, 2p3. But if we take oxygen, s2, 2s2, 2p4, p4. 1s is already participating, that does not affect the whole structure, but A is the 2s, in 2s, total 2 electron, that forming an 2 bonding orbital and 2 non-bonding, that is total 4 electron. After that, the p orbital here and that p orbital, it has lesser energy because the electronegativity of oxygen is compared to nitrogen. That's why its energy barrier, you can see this energy barrier is lower. In this case also, you can see this. The energy of this is less as, that's why its energy of a atomic orbital is slightly decreased due to its electronegativity. But nitrogen, its energy barrier is slightly, that can corresponding to give atomic orbital, uh, molecular orbital of a different uh, energy level. This is pi 2px, pi 2py, sigma 2pz. Total is 3 plus 4, total 7 electron, means 1, 2, 3, 4, 5, 6 and total That's why the here is highest occupied molecular pi to pi star p x and lowest unoccupied molecular orbital is pi star p y. This way. This is the lowest unoccupied and high occupied molecular orbital. And this is highest unoccupied orbital because it is in highest energy level. Occupied means there is this is molecular orbital, highest unoccupied. And the electronic configuration in this consider, then the electronic configuration we can write in this way. One s two s two sigma 1s 1 star comma 2s2 then 2s2 star pi 2px 2px 2px2 pi 2p y 2 and sigma 2p 2 and pi 1. This way. There is some problem in writing pi and sigma. That's why I write pi. Next is linear combination of an atomic orbital, LCAO. Linear combination of atomic orbital is come from an quantum supercomposition of an atomic orbital. We will calculate according to quantum how much contribution of an orbital in form of a wave function, and total electron in this case we can easily calculate it using an quantum wave function. It was discovered in 1929 by John Leonard Jones with the description of a bonding and diatomic molecule of first main periodic table, but it has been earlier by Pauling. Pauling is the scientist in which they discover the two theory. One is from the electron are filling one, and next is the electron are filling according to its energy level. The linear combination of an atomic orbital in form of a function, either it is form of an addition or subtraction. The addition atomic orbital in form of a wave, it form an bonding molecular orbital. If we can say the contribution of A and B, it is either in the form of a positive and negative. This is the way. But if we consider the bonding, there is a addition of a psi A and psi B. But if we consider bonding, it is the subtraction of wave function in form of a psi A. If like a if ss orbital is combined together, this is sigma s which has higher electron density. But if subtract the electron density, there is a anti-bonding molecular orbital, but it has an decrease its electron density. That's why there is a node where is the electron density found is zero. Here is electron found, density is zero. Next is according to LCO, we can represent the atomic orbit energy level. Here is the combination of bonding atomic is a increase in the electron density, means there is a formation of an electron cloud in this case. But if it is decreased electron density, means there is a formation of a node. Here is the node. This is the anti-bonding. This is the bonding. 1s of one hydrogen combined with second 1s hydrogen, there is a formation of linear combination of atomic orbital, and the energy of a bonding molecular orbital is as compared to anti-bonding. For both the electron combining the atom that can attract to it. But in case of anti-bonding, the electron tried to move away from the nucleus. That's why repulsion and the energy gap is increased in this case. That's why anti-bonding molecular orbital has higher energy as compared to both. This is the main reason. Next is how the atomic orbital according to its wave function. If we take an example in form of a, either it is in the this direction or this direction. If positive to interact, there is a formation of an higher electron cloud here. Higher electron cloud sigma 1s. Density is increased. But if positive lobe that is with negative lobe, there is a decrease in the electron density. This is slightly decreased. Slightly decreased means the crust is interacted with trough. The positive is interacted with the negative way. There is a decrease in electron density, or we can say there is a decrease this way. In this case, electron density is increase. But in this case, electron density is decrease. Then we will come to higher uh, then we will come to higher atomic orbital, like in case happen, we will discuss in next class. If any doubt, please raise your hand. Up to that, if any has, please raise your hand.
Sir, what happen if negative lobe interact with negative lobe?
Negative lobe acted with negative lobe, there is a formation of an bonding orbital. Bonding orbital means the electron in this case is in negative direction, but electron cloud is increased. There is some scenario if positive lobe is interacted with negative and negative interacted with positive, there is a change in the this way. If any doubt with other student, because in case of a wave function in form of a wave, wave means एक बार ऊपर आएगा एक बार नीचे गिरेगा. वेव कैसे आती है, एक बार ऊपर आती है फिर नीचे गिरती है, फिर ऊपर उठती है फिर नीचे आती है, ऐसे ही मतलब इलेक्ट्रॉन क्लाउड भी आपका ऐसा ही होता है। एक बार पॉजिटिव लोब है, दैट इज इंटरेक्टेड विद पॉजिटिव, मतलब अगर एक वेव के साथ में दूसरी वेव इंटरेक्ट करती है तो वो और ऊपर उठती है। और अगर वेव के साथ में अगर नीचे कुछ मतलब आपका जो स्केल है वो नीची हो, मतलब समुद्र से अगर नीचे वाला होगा कुछ डाउनस्ट्रीम होगा तो वो वेव नीचे तो गिरेगी ना, तो इस वेव से इलेक्ट्रॉन भी। Sir, in NO case, why starting electron from 2s? What about the s orbital? S orbital is same because in case of a s, it does not interfere because it is closer to nucleus. That's why its participation does not matter because it is in one orbital, sigma 1s, sigma 1s. Then there is a formation of two the orbital, one is from bonding, second is from anti-bonding. There is a sigma 1s2 and sigma star 1s2. If we will see, wait, in this case, if we take 1s here, 1s and 1s, there are two electron. Here is also two electron. 1, 2 and 1, 2. That also forming a same this way, and this is sigma s and sigma star 1s. Here are total 4 electron, 1, 2, 3 and 4 total. That's why the contribution of s orbital in this case is we cannot consider because it is a closer to nucleus and it does not affect the energy barrier. In this case, energy barrier is slightly up, but in this case, slightly down. In case of oxygen, because electronegativity of oxygen is slightly higher as compared to nitrogen. That's why the energy gap, the 2p and 2p is slightly lower in this case and slightly higher in case of a nitrogen due to electronegativity difference, and that can form an bonding and anti-bonding molecular orbital. In case of a, these has, according to VBT, these has same energy level. Same energy level means in case of if we take an example according to VBT, if we take an example that has similar energy here, here is the atomic orbital, and that can form of a diff that can combine to give different molecular orbital which has same energy. But according to MOT, the atomic orbital of a different energy level, that 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 after combining after combination with bonding, that give different molecular orbital which has different energy level. But according to VBT, the same atomic orbital which has say similar energy after combination with bonding, that can give same energy atomic orbital, sorry, molecular orbital. This is the main difference between the MOT and VBT. In next class we will discuss about the higher hydrocarbon, like in case of a CO2 what will happen, in case of ammonia what will happen, this type of a higher atomic orbital. We have considered up to two molecule. This is the diatomic. Diatomic. In case of a diatomic, there are a two category. One is hetero, second is homo. In this case, it is a hetero. But if in this case, like a B2, C2 and N2 this way, this and this oxygen, nitrogen, this is the homo. If any doubt, please raise your hand. There are a different theory for different scientists, but the main theory come role into play is the MOT. Because of a different scientists give different opinion, but they they failed according to some limitation. According to Levis theory, that tells about the octet rule. According to octet rule, that does not give the geometry as well as the electronic configuration, how the participation of a pi bond. He does not explain. After that, next theory come, that is VSCPR, valence shell electron sharing pair electron. VSCPR means that the electron are filling according to its energy level, and according electron are filling one by one, but he does not explain about same about the transition metal complex, also the higher molecule. Also, he does not explain the pi bonding as well as how non-bonding or lone pair of electron is participating in bonding. That is the limitation VSCPR. After that, next theory come, that is according to that is the VBT, valence bond theory. According to valence band theory, it tells about the participation of an different atomic orbital which has same energy level after hybridization or bonding, that can give same energy level, but it does not true. And also it does not tells about the bonding as complex. This is the main. After that, next theory come, that is MOT, molecular orbital theory. According to molecular orbital theory, the different atomic orbital which has same energy level or maybe different energy level, but after hybridization or after bonding, it give different molecular orbital which has energy. This is the next or final theory according to MOT. It tells about for covalent molecule. Then for coordination, it also tells about the coordination complex. That's why this theory is reliable and final for the participation of an bonding, and also tells about the hybridization. If any doubt, please raise your hand. Otherwise, we will continue the class. Yes. Hello.
Hello, hello.
Yes, yes. Tell.
Sir, why is mitochondria powerhouse of the cell? And where is the power comes from? Very important, sir, question.
Where is the mitochondria?
Sir, why is the mitochondria powerhouse of the cell? And where does the energy come from?
In
And sir,
the case of a mitochondria, there is the nucleus. Nucleus means the energy. In this case, the electron cloud. The electron cloud is very high. That's why the energy in mitochondria is we can say it is a powerhouse.
Also, sir, I would like to complain about Krishna Gupta. He's been bullying me for a. I would like to cry, sir. I am going to die. I'll kill myself. Please, Krishna Gupta, sir, punish him, sir.
Any doubt? Otherwise, we will continue the class for polyatomic molecular orbital. Okay, student then.